Hello, my name is Chandler Sanchez, and this is our Tetrix programming.
What problem were you trying to solve using the Tetrix robot?
The programming that our group was trying to solve with the Tetrix programming was that we were trying to make a grid out of 4 2x2 squares. Our robot was supposed to successfully go all 4 squares without being lifted up and to make the grid.
Explain how your group solved this problem by explaining your Tetrix programming. If you didn't finish, explain what you would have done to solve the programming.
For our programming, as you can see, we wanted both motors to go forward and do a basic square. After that basic square, we wanted it to wait for a second, and then it would have to stop and do a square, and then turn, and then it would turn right.
Explain what each of the parts do in the program.
These parts are the left and right motors, and they depend on the motors, whereas this is the power that it was going at 40. And as you can see, it did this for 2 seconds, with 70 seconds as the other motor, making it turn into the squares. Then you can see the time it waited for the second, then going forward, and then doing the turn with only one wheel, with only one motor, so that it would only make a 90-degree turn. Then we made it stop, and as you can see, we repeated it 16 times, which was the amount that we needed for it to go in a square 4 times.
So what would you have done? You didn't finish, correct?
Yes. No, we didn't finish.
So what would you have added?
The main things that we would have added is we would have wanted to tweak the angles a bit and the side lengths of the square for each square, because of our grid, and it wasn't exactly 2x2. Each square wasn't exactly 2x2.
Okay. How did you use patterns to solve the Tetrix robot challenge, and how would this transfer to other programmers and their programs?
The main patterns we used is we used a pattern of a simple go and turn and go and turn, and that can be used by repeating it on and on, basically. And it makes it easier to make something like this, where it's just 4 repeated grids in different places, or 4 repeated squares to make up one grid. And this can be used by programmers and them, because it's just a very simpler and faster way, and non-complicated way, and more organized way to do something on this type of platform.
Okay. And how does what we are learning in math about transformations apply to solving this problem?
This actually helps a lot with not only transformations, but also rotations, because of how far you need to rotate it to turn it, and how that factors into it. But the translations, it helps a lot, and because and it factors into this whole Tetrix, because it shows us like how we have to move it and where we have to move it to make it the best possible platform, and how we want to make it. And the transformation shows us how we can what we need to do, and it helped a lot.
What transformations did you use in your robot?
The main transformations that we did use were a basic we tried to make a basic 2x2 square, or 2 feet by 2 square, and we, as said previously, repeated it multiple times in order to make the grid.
And what transformation is repeating?
The repeating transformation is the square, which would be down to right to which would also be considered our rotation.
Okay.
Yeah. Thank you.